I'm really excited to share some of my thoughts and some of the work that me and my colleagues have done at PNNL. And on the screen, you're seeing a list of my collaborators at PNNL who I've worked with, in trying to explore this dimension of large language models. And I'd like to share some thoughts on grid operations and planning. Um, but oops. Okay, so I'm gonna be sharing some of my thoughts, but I'd really like the audience, the crowd to just think about, or just share information on what people are doing, what are the thoughts on LLM grid applications, if there are people who are working on any active projects using LLMs, if they're planning to, if they're thinking about, or are eager to explore it. If people have thoughts about what are the potential use cases that you foresee for LLMs and concerns that need to be addressed. So at any time of this talk, either at the beginning or the end, in the middle, if you feel bored with the presentation, feel free to share your thoughts on the chat. And I'm really interested to know, what you're working on and what your thoughts are about this topic. Okay, so here's the agenda, or here's how I've split up the talk. First, I'll just talk briefly about AI and large language models, or LLMs. I'll share some of the current industry adoption examples that I've found from internet searches. Next, I'll be talking or delving into some of the LLM applications that we've developed at PNNL, including ChatGrid and a few other applications. And lastly is the time for any discussion, any questions, and having an open conversation on LLMs in general for grid operations and planning. Okay, so the first part is on artificial intelligence and LLMs. In the recent times, artificial intelligence is a big buzzword, not only in the grid industry, but in all industries in general. And it's a very big term, and it encompasses a lot of different things. And if I have to just summarize it is basically trying to recreate the intelligence of living beings in a machine. So it encompasses a lot of different things. And really, this quest of trying to generate intelligence started off with, what are the mathematical formulations or concepts that can be used for recreating these intelligence. And so there was this era, or there's still this era of machine learning, wherein you have these different statistical algorithms, be it regression-based, classification-based, Bayesian, and so on and so forth, early work on neural networks. So that, everything, trying to create these statistical algorithms can be, framed into the machine learning parlance, but it's just a subset of artificial intelligence. There is genetic algorithms and other evolutionary algorithms as well. But really, this artificial intelligence field started taking off in the early 2000s with this advent of deep learning, which is basically what I call as artificial neural networks on steroids. So you have these deep layer of neural networks instead of having a long layers. And along with these different layers, you also have the compute power. So when people started using graphical processing units, there was a paper, the first seminal paper on this was on using graphical processor units for these deep networks, and was found that the graphical processor units can really accelerate the computation of these deep learning networks. And that's kind of, set the stage, revolutionized. And there were a lot of applications that were enabled because of this revolution. The couple of applications in this space. There's computer vision, so anything related to gaming industry, other computer vision applications, and then the other application was on natural language processing. So you had applications such as Siri, such as Google Voice, and others, which would communicate with us humans in a natural language. There was another revolution, starting around 2014 or thereabouts, which was generative AI, and this was a different type of AI as compared to our traditional AI, which does this mapping from input to output. And generative AI was more of this creative sort of AI, where it is creating new content. And there is the intersection of computer vision and generative AI led to this applications such as generating images, creating or trying to figure out new images or trying to fix images and so on. What I'm going to be talking about is this intersection of NLP or natural language processing with generative AI, which is essentially where the world of large language model delves in. So there are these different applications or different products such as ChatGPT, Gemini, Cloud, Llama, and others that have really spurred this field of AI in the last, I think, about 5 or 6 years or so. And from large language model now it is going to multimodal because they can also ingest video data or the spoken data as well. So there is a lot of advancements that is going on in this LLM industry, and that's what my talk is about today. So first, let's look at what is meant by generative AI and large language models. So briefly, as I mentioned, generative AI is something that creates new data. So it is a generate new content based on prompts. It's a creative AI, so it can create text, code, articles instead of this traditional AI, which is the predictive AI. The predictive AI tries to map the relationship between your inputs and outputs, whereas the creative AI basically tries to learn or tries to generate what comes next. And with the LLMs, it's this kind of daisy chain of words that are spelled out that create the content. Generative AI, a large language model, is trained on a very large data set, or what is called as a corpus. And here's just a simple example. This technology has matured to such an extent that it can generate nicely, nice content, formatted content, very brief. You can add constraints to it saying that, just generate me in 200 words, XYZ thing that I want to know about, and it will create that content. And so this is an example of that. But really, what has in my opinion, what has revolutionized the field of AI is this ease with which humans can now interact with the machine through natural language, and the technology in itself as well advancing to such an extent where it can provide answers to the questions that the human is asking to some degree of satisfaction. And that's why this technology has gained popularity. All right. So in terms of the industry, how is what is this technology looking at? So if you look at the evolution of LLMs right from 2020s up till now, there has been an astronomical growth in technology with more number of training parameters, going into billions and now in trillions. There are various companies that are producing LLM models. Some of them are closed, some of them are open source. And the data that is being ingested by these models is growing more and more. And this chart basically sums up to, I think, late 2023 or so, what these different technologies are. If you need more information, there is a source given over here. You can take a look at the source. It has great information on LLMs. In terms of the market also, if you see, there is an expected growth or kind of a large growth in this market. And nowadays we are kind of used to LLM generated content, be it from search engines, be it from GitHub Copilot, be it from your VS Code, or other sources. There is more and more integration of LLM technologies in the everyday tools that we're using, and that has really spurred the market as well. And the chart over here shows the different or the projection of this LLM market, and also shows what are some of the base case or the use cases for LLMs. So when I talk about LLM, there are these LLM products such as your ChatGPT, Llama, Gemini, Cloud, and so on and so forth. But there are these other tools that are in the LLM ecosystems that are needed to help the LLMs compute faster, do data management more efficiently, as well as have people start using it. So be it prompt engineering or your vector databases and so on. There are these assisting tools that are really needed, and that's what has made the LLM so popular as well. On one side, you have a very thriving industry that is that is growing. The market cap is going, and also the acceptance of LLMs for everyday use that is also growing. Some of the base case use cases that have been talked about, I can kind of sum it in 5 categories. The first category is in content generation. So this is basically the LLM can write you text, document, write summaries, write poems and other textual content. Information retrieval, if you want to search from the internet, if you want to search from your local database, then it can, or from a document, it can retrieve that information, it can summarize it, and so on. Virtual assistants, people have talked about planning their next vacation. If they're going on like a 7-day vacation somewhere, the virtual assistant will plan the schedule for you, or basically it's kind of a scheduling sort of an application using virtual assistant. Sentiment analysis and code generation, which is heavily used in the computer science industry, where some pieces of code can be generated, be it Python, be it C, C++. There is a variety of code that can be generated. Okay, but with LLMs, given that this is such a new technology, it's just basically 5 or 6 years old. There are challenges and concern as with any new technology, and is a list of challenges. Hallucinations, wherein basically it tries to produce an answer which is supposed to be creative, but it's not based in any reality. Bias can come with the data that gets fed to it, and there are a number of different challenges and concerns. And over the last 4 or 5 or 6 years, this technology has been addressing these challenges and getting more and more better in terms of the information it is providing. And these challenges will be there, but the rate at which these concerns are being solved is good to see from the LLM industry point of view. Okay, so that was kind of a brief whirlwind introduction of LLMs. I'm sorry, I'm not delving into any of the architecture, transformer architecture, or how, what is inside of an LLM. That is not in scope of this presentation. So if there are some enthusiasts who want to know about, what is inside the LLM, they can probably look it up on the internet. But this is more on, what LLMs are, how can they be used, or what is the industry adoption in the power industry, as well as I'm going to be presenting some of the use cases that we've developed at PNNL. So in terms of the current adoption of LLMs in the industry, just doing a brief search across the internet, one can see that this is a new technology, so its adoption, there are some ongoing pilot projects which have been which is mentioned in this Capgemini Research Institute report. And there are a lot of these different press reports or press releases, or products that have been already announced that used LLM. So Itron and Microsoft Azure OpenAI, or C3 Generative AI. ETAP is a vendor, it's a distribution system simulation vendor that has announced an electric co-pilot. Schneider Electric has announced generative AI as well. And these are probably a subset of the use cases, and there are probably more use cases, or more industry use cases as well. Okay, in terms of potential grid operations and planning use cases, again, this is probably a subset of the use cases. So going from what they can, or the potential information extraction from reports or manuals or guidelines. So you have your simulation manuals or something. Those can be automated, streamlined. Those can be made easier by using LLMs. Summarizing of big reports or big documents, that's another use case that is possible. Compliance and review. So if you have like a compliance, then to generate the documents for compliance, or reviewing it, checking it, validating it. That's another thing, virtual operator assistant. And there are a number of use cases that are possible. And I'm really interested to also know from the audience what use cases that they are envisioning or that they are working on or that they know of. And if you could please put it in the chat box, that'll be great. Okay, so next up, what I wanted to share is some of the work that we've been doing at PNNL on LLM applications or applications of large language model. And I'm going to be talking about ChatGrid, which is a tool that we've developed, which uses OpenAI for grid operations. Before I talk about ChatGrid, I just wanted to acknowledge and mention about the project that started ChatGrid. So there is a project funded by the Department of Energy Office of Science, and the project was for creating large-scale grid optimization for for the next generation of computing technologies, which will use GPUs, and trying to come up with the largest possible or very large scale optimization problem. So we've developed this toolkit called Exago, which is open source. I have a QR code for that you can later on see. And here, basically, we are trying to run these large scale AC OPF or AC optimal flow, AC optimal power flow applications with these 3 dimensions. So incorporating N-1 or security, contingencies, incorporating uncertainty, which is your wind generation or your renewable generation uncertainty, and as well as scheduling, which is your time. It is high performance, so you can run it on large number of clusters or large number of processors, as well as you can run it on your laptop as well. So it is portable. It uses heterogeneous CPU and GPU. You can run it either on CPU and GPU. And then there is Python API visualization, which is part of ChatGrid as well. So some of the details of Exago, I mentioned about this 3 dimensions of security, uncertainty, and time. There are these different applications and solvers. So we have AC optimal power flow, multi-period OPF, and others. We use some of the open source libraries for the optimization, HIOP, IPOP, and tau. And there is a bunch of details that I've mentioned over here, including what is included in the ACOPF, what sort of algorithms we use for large-scale parallel computation, which is this distributed algorithms, and lastly, some details on the GPU implementation, wherein we port our data on the GPU and then do all the calculations on the GPU for this ACOPF. So the project that funded this, which was this Office of Science, NNSA, its end goal was to run this application or run this large-scale grid optimization on the currently the fastest supercomputer, which is hosted at Oak Ridge National Lab called Frontier. And so Exago was run on Frontier on the Western Interconnection full 10,000 bus synthetic model with about 100,000 what if scenarios, which included wind uncertainties and contingencies. This was about a 7 billion variable AC OPF optimization problem. And at the full scale of Frontier, which was about 8,000 nodes, we were able to solve this problem under 20 minutes of execution time. So we were solving this AC OPF problems, and we were generating a lot of data with it, which is pretty large data. And so one of the things that we wanted to do was, how can we make sense of this data and how do we analyze this data? So we started creating this visualization, which you see on the map over here. But quickly we came to the conclusion that as in when we want to see more patterns, as in when we want to get or retrieve more information from our data sets, we had to code that up in the visualization, which was very very demanding, which required a lot of time and effort. And that was a time when there was a big popularity of OpenAI or ChatGPT, and that's when we started thinking about can we retrieve our data through OpenAI or ChatGPT, and can we connect our simulation and our visualize our data with ChatGPT so that we can query the data directly, as opposed to you having this graphical user interface. And so that's where this idea of chat grid was born, which is basically connecting your data, which could be your simulation data, or it could be your actual data, with a generative AI or chat GPT. And so here, the paradigm here is basically what you see is what you ask, as opposed to what you see is what you select. So there are no widgets. You can simply ask a question and it will provide you the answer. For example, what is the remaining capacity of generators that have, some capacity more than 100 megawatt remaining? And so it will provide you, it will query the data, it will provide you the text-based answer, and it will also visualize on the map where those assets are. And I have a demo later on which will show chat grid in action. We have a paper that was accepted for the EnergyWiz conference. Happy to provide you links for that paper as well. One of the main things that we had to figure out in this is, how can we use ChatGPT without sharing any of the simulation data with it? Because if this technology is used in the real world, then because of the criticality of the data, you cannot share the data with ChatGPT, unless it is in-house and it has the necessary security features. But for us, we were using ChatGPT through the API servers, and so one of the things that we wanted was, not sharing any data with ChatGPT. We could share some generic metadata, but not the actual data. And this also kind of came to the insight that we are kind of approaching towards this next generation of interfaces. Back in the day, in past, in order to communicate, or in order to interact with the machine, you actually had to type in the command. That was superseded by the present technology that we have right now, which is the graphical user interfaces, wherein you have drop downs and you have widgets and everything by which you can access the data. So it's kind of this intermediate medium between your data and the question that you have. But with LLMs, now you are moving towards this interface wherein you will ask a question and it will communicate with your, you'll have something that will communicate with the data directly, and it will fetch back the answer. So there is no middleman over here. It's basically the question that you ask and the answer that you get. So it's what I call as QUI, or question-based user interface. There are obviously advantages of this, which is there's faster analysis, because now you can get the answer to the data directly through your question. There's seamless data access, which I mentioned. There is no intermediate factor. Hopefully that will lead to faster decisions, and there is equitable access as well, wherein you can ask the question, it will generate the data, and your boss can ask the question, or your subordinate can ask the question, and it will generate that same data. There is also a reduction in the learning curve. You don't have to read the or know exactly how to read how the program works and everything, and know that in detail. It's basically you start off with a question and that's the answer that you get. As I mentioned, there are challenges that need to be overcome. What is the accuracy of the answers that you get? What is the latency? How fast can it retrieve the answer? Hallucinations, whether it hallucinates. And lastly, for our industry, security is one of the main challenges as well. How do you keep your data secure without sharing it with any of the LLM vendors? Okay, so this is I'm going to present a quick demo of ChatGrid, and what you'll see is a quick, we had asked ChatGrid some questions on the data that we were using. So remember, I mentioned to you this is a synthetic model of the Western electric grid, and it will we are asking it a bunch of different questions. So list generation with capacity higher than 600. And it will produce, what those names of those generators are, and it will also visualize on the map where those assets are. So the bars here correspond to the different generation, and the colors correspond to the different fuel type. So blue is hydro, red is nuclear, orange is natural gas, and so on. And we asked, we ran through a bunch of different questions based on different question categories. So here is a category on selection of a set, which is list different categories. Now this is a logical inference query, so list all the wind generation capacity higher than XYZ. And this is a fairly long video, about 4 minutes or so. So I'll quickly go through some of the other questions. Negative connectivity. So list names of all generators except for the wind generators, and it will provide that information. The top 5 coal generators that generate the most power, it will provide that information. And so the data that was used for this was basically the output from our AC optimal power flow from Exago. And that has the network flows, that has the generation capacities, voltages, loads, and etc. One of the things that we also saw was it was able to understand spelling errors, as well as it was able to understand similar words. So when we asked robust generation, it was able to understand that we are actually asking for the generation, the generator with the most capacity. Or if we typed in the wrong coal, CAOL, it was able to do that. Storage here again means capacity, so it used synonyms. And you can do aggregates by count or group by how many generators are there, most remaining capacity left. We also could connect it with just a county, so which generations are in California or the state, for example, and it would provide us with the generators, and it would show on the visualization what they are. And the transmission lines, it would provide the information on transmission lines and produce that as well. So ChatGrid is available open source. There's a GitHub repository. It is a part of the Exago library. So if you go to this GitHub page, you will see Exago, and ChatGrid is available there as well. Okay. Okay, so next I want to talk a little bit about what's under the hood, what tools we use, how do we make the connection from LLM to visualization, and some of the other details that. Okay, so before I talk about the details of ChatGrid, I just wanted to I think mention about how do you access the LLMs itself. So there are two ways that you can access the LLMs. The first way is you have ChatGPT or you have Llama or other at a server which is on their company devices. So for example, API, wherever the API servers are there, you can connect with that server through API calls. And so this is outside your company facility. So this is outside your cyber security for the facility. So this is just done through API calls. The other way that you can do it is actually install an instance of that LLM application in-house in your own facility. And you can then connect with that LLM server. So there are these two different ways. API calls, you can access the LLM via API calls. LLM versus in-house, you basically build the LLM on your facility. For API, you have to pay for the price per API call, which are tokens. There are different models that are available, and each have their own pricing system or their pricing. With API calls, it's less secure, because now you are communicating with something outside of your facility. Whereas with in-facility or in-house developed LLM, it's more secure. On the API call side, you can have more models. So you can have a GPT 3, 4, 4.0, and so on, or different versions of Gemini. You don't have to also it's managed by somebody, so there is less investment in deployment and maintenance. So there are these two different ways of how you can access the LLMs. Once we know how to access the LLM, then the question is, you have your local data. So how do you ingest that data, or how do you make that data available to the LLM? So there are these, again, two models that can be used. The first one is what is called as a fine-tuned model, which basically wherein you provide the data for training the LLM itself. So all that data is used for training the LLM. It's for setting the weight. The LLM might come with its own set of weights, own set of trained parameters, but you will also provide it with your local data to further fine tune that LLM for your specific needs. So you fine tune the data, but the challenge now it has access to your local data. So if you're using with API calls through some third party server, then this is very bad because you're sharing the data with that third party. Also, wherein, when it comes to numeric data, which is what you get from a power flow or your EMS systems, training with that data is not, it's not good for the LLM, because it's not based on a model which is used to seeing a large amount of numeric data, so it can have poor performance. There is also a challenge of retraining with new data. So if you have some new data coming in, the fine-tuned model needs to be trained again for that new data. The other side of it is what is called as RAG, or retrieval augmented generation. And here, basically, the concept is that you will not train the LLM with your data. The local data sits separately, and you will query your local data using the LLM. And so there are different ways, or it depends on how you store the data. So there is no training or retraining that is required, since the data is stored separately. And you can access the data using queries generated by LLM. So for example, if your data sits in an SQL server or SQL database, the LLM will generate the SQL code in order to query the data. And there is this nice data and LLM separation, and there is no retraining needed for the new data. So for ChatGrid, we use this RAG model, or retrieval augmented generation model. And then we were using this API calls, which I showed in the API calls. So we used to communicate with the OpenAI servers directly. Okay. And this is kind of the architecture or the flow of data. And I'll quickly, go on this. So basically, what is happening under the hood is the user asks a query, for example, which generations are in California. We have all our data stored in SQL database, and it need not be SQL. It can be on any other database, Oracle, PyHistorian, and what have you. We used SQL database. So all our data is stored in SQL tables. So you have, for each SQL table, you have a table header. And what we provide to ChatGPT is we provide the table headers. So, basically text such as generation, capacity, lat long, transmission flow, and so on. And we ask ChatGPT to give us back a SQL code that we can run on our local database. So this is the RAG model, what I talked about. And so ChatGPT will look at the question. It will look at the table headers that is provided, not the actual data. And it will return us back with the SQL query. And we take that SQL query, run it on our SQL database, produce the answer, and then feed that to our visualization. And then the visualization will visualize the output. One thing that we realized is LLMs or any ChatGPT or anything is good with simplistic visualizations, like it can generate a bar chart or a pie chart or something else. But when you have complicated, like a network topology based visualization, it's not good with that. So we had to develop our own visualization and connect it with this. One of the advantages of this model here is that, again, as I mentioned, we don't share any actual data with ChatGPT. It's just a table header, which are very generic, that we use. And that's what this is the model, or under the hood, what is happening with ChatGrid, and going from the question that you put in to the visualization. This is what goes on. One of the things that we did invest time in is to check the accuracy, or basically how reliable are the answers. And for that, we came up with these different categories of questions. This is just a subset. If you read the paper, it has more detailed information about what the questions that we asked. And we tried different input formats: text, SQL, JSON, and really tried to see which data format works best with ChatGPT. So with text format, we actually converted the data to text, and tried to see whether basically just wrote paragraphs from our numeric data and tried to see whether ChatGPT is able to answer these questions better. But consistently, what we found in our assessment, or when the accuracy assessment, is when you use SQL data format, when you have the data in an external database, and when you ask ChatGPT to generate code that can query your data, it tends to give better answers than if you just feed data to it. Lastly, I think this is probably the last slide of ChatGrid. So there is a lot of behind the hood tools that we used. Going from the visualization itself. So front end, we use Node.js, React, some visualization libraries, and we are using JavaScript over here. I know Python is a very popular language for visualization, but when it comes to kind of creating good visualizations, Python lacks that capability. So we had to go with the JavaScript route. We found a library called DeckGL, which is a open source library by Uber, which is fantastic for visualization, geo visualization, because it keeps all the data on the GPU, so it is much faster. It does filtering and scanning and everything much faster. For the natural language query process, or where ChatGPT is connected, we used LangChain. All our data was an SQL database, and then we used the OpenAI LLM model, 3.5 Turbo. So that's what we were using. Okay, so what I showed right now with ChatGPT is more on the operational side of things, wherein if you have your data coming in, or you have your pre-stored data, then you can use ChatGrid to interact with that data. And so we use the same concept and applied it for long-term planning analysis. And this is one of an important applications in the power industry, where you want to know how the grid will look like 10 years down the line, 20 years down the line. And so the applications that are in this space are long-term planning applications. They project the grid in the future and try to analyze whether the resources are adequate, whether there are any problems with meeting the load, and so on and so forth. And so we have this initiative at PNNL called Go Deep, which is Grid Operations, Decarbonization, Environmental, and Energy Equity Platform. So this was a laboratory directed or LDRD initiative, which was doing these long-term planning studies. They were doing studies of 2050 with different levels of decarbonization. And each of this study had multiple scenarios, and each of the scenario was an year-long simulation. So for example, a simulation of how the grid will be in 2050. It's a year-long simulation at an hourly resolution, so 8760 hours, so 8760 power flows on grids as big as Western interconnection. And each of those scenarios generates about 3 to 5 gigabytes of data. And analyzing that data, managing that data, trying to figure out patterns from that data requires a lot of manual effort, because you need to write those scripts. You need to create that infrastructure by which you can easily analyze what you're looking for. So we applied that same concept of ChatGrid to these data sets. and tried to see how it can help with analysis of this. So we had this um, like a tool called Grid Copilot, wherein it's connected with that data set. It produces the visualization. It produces the bar charts, what are needed for, or not necessarily bar charts, but the different charts that go along with trying to understand what information is provided. But because I feel just text information is not enough, once you see plots or charts or visualization, it's much better to understand. And we talked with the people who were working on this project and try to get their feedback on this. And one of the things that we consistently heard from them was that this sort of a tool helps really in the analysis part, because they don't have to write scripts themselves. Or if there is a new person who has joined the project, then it takes time for that person to get up to speed with the project. And having such a tool really helps in productivity, reducing the analysis time from days or hours to minutes. So this was for long-term planning. Another project that has been done by my colleagues Yuan and Kelvin was on the input side of things. And so their work is on, routinely when you want to do some analysis, you want to create these different scenarios. And so how can you um, increase productivity in creating those scenarios? So they're working on this project called Intelligent Power System Data Management Platform. There are a lot of moving pieces to it, but the one piece that I wanted to highlight here was that, given a user query about a certain grid, a certain level of, or a scenario that they want to generate, it will generate the Python code that is necessary for creating that input raw file or modifying the input file that goes along with this. So here, for example, here's a question of write a Python code that checks and increases all generators in just area 1 that are under 70% and increase that capacity by 10%. So it is able to generate the Python code. And at least it's able to do like bulk of the work, so that then you can make the last tweaks and create these scenarios in matter of minutes, as compared to spending a lot of time on creating these scenarios. Okay, so this is my last slide. And so I wanted to just leave with some final thoughts on, or some thoughts that I have on large language models in general, based on the work that we've done over the last maybe 1.5 years or so. So large language models, in my opinion, it's a promising new technology because it eases the data access and analysis particularly. So it will not replace any of our simulation engines. But what it can do is it can increase productivity for creating the inputs as well as analyzing the outputs. There is ongoing adoption in power sector, which is just beginning. And in my opinion, again, widespread adoption is eventually inevitable, but it needs to be really thoroughly tested before it is used in critical grid applications. So it's going to take some time, but now is the time really to figure out what those use cases are. How can we make sure that we embed the necessary reliability and security in these applications? Some of the current and new directions for large language models. There are these models which are now not large. These are very targeted, called small language models, so less parameters, very fine-tuned to specific application. You can have multimodal now, wherein you can feed in images, videos, text, and so on. Right now, if you look at LLMs or small language models, they're good for data retrieval. They are good for data exploration. But if you ask a question like, is my system secure or reliable based on the data that I have? They won't be able to answer that question unless you provide it with the context of what it means by security, what it means by reliability. And so there is this also notion of, how do you make the LLMs understand what these larger big picture questions are. Input data for generation for scenarios, what I talked about. And lastly, I'm really interested to collaborate on projects where LLMs can be applied for grid applications. What sort of different applications do you foresee? So, if you have any thoughts, if you have, just want to drop me an email about, something that you're working on or something that you're interested, feel free to contact me. My email address is given over here. I want to acknowledge, obviously, the funding that was received. So from the exascale computing project, as well as for the LDRD initiatives, both for Grid Copilot as well as for the intelligent data platform. And with that, I want to thank you for your time for listening.
Thank you, Shirin. This is a wonderful talk. From the audience, there are questions. The first one is from Patrick. He says, really interesting product. Has there been applications in Europe based on your understanding? His business is supporting the sector and can see several applications in the energy transition.
Sorry, could you repeat that question? I didn't quite catch it. What was the question exactly? Are there
The
any
question,
applications in Europe? Was that the question?
right? Do you know, has there been applications, I guess, of your product in Europe, or maybe other applications like Chat GPT, Chat Grid for Europe?
So for Chat Grid, no, not yet. But we are open to have a conversation with if there is interest in exploring how Chat Grid can be used for any of the applications in Europe. Um, there is a product that I know from Europe called Grid Chat. I think and I may be wrong over here. It may be from RT France or some other team, where it was more of a conversational platform to answer grid questions. But I haven't accessed it yet, so I don't know exactly what it is. Yeah, but that's the answer to that question.
All right, thank you. And then there's a question from Prakash. He says, Shri, very interesting work. Have you tried with ChatGPT? Some questions is like, please list all the congested lines, list all the marginal generators, and there are other questions is, but have you tried the first two, like list all the congested lines and marginal generators?
Yeah, so we tried, for example, the visualization that I showed, wherein the data, since we were running an AC optimal power flow, what it will do is it will try to reduce the congestion. So for our data set that we had, it was just lines that were loaded above 50, just below 50, above 50%, I guess. But we've tried to see, basically given a percentage of loading, so 80, 90, or it can be even 100. So those were, yeah, so we were able to get answers from ChatGPT on those. We haven't, so here's where the question and answers part, or the prompts, come in. We haven't tried a prompt saying, show me all the congested lines. And that's something that I think we should try out. But it's similar to, show me the lines which are loaded about 80% or 90%, right? Because it has the kind of the same connotation. On
Right.
your other question of marginal generators, we've again sort of asked ChatGrid about, show me the generators that have less than 100 megawatt capacity remaining, or headroom, basically. And it's able to show those, it's able to answer those and visualize those. Yeah.
And the next two questions are, what if the handlers have improper names? In such a case, how does ChatGrid understand?
Sorry,
And
I
also,
didn't get the first part.
yeah, the first part is if there's improper information, I mean, from the data you provided, and then how does ChatGrid understand?
Yeah, that's an excellent question. And so what we've tried to do was provide, ask. So we created this category of questions wherein you have typos in the questions. or you have some question that is, um, you know, it does not use the correct terminology that the grid operators and planners would use. And so in those cases, given those typos or the synonyms, ChatGPT or ChatGrid was able to understand that this is the question being asked, and it was able to answer that. But if it is something that is not in the data, then we've tried to make it such that it will say that I do not have this in the data, as opposed to trying to hallucinate or trying to figure out the information. One of the things that we are doing over here, as I mentioned, is we are using a RAG model.
Mhm.
So it will generate an SQL query, and it will then try to fetch that data from your database. So if it cannot fetch that data, then we basically say that, we don't have information on that. And that's much better than, coming up with a very creative answer that is unrealistic. And this is a very, very open topic as to, how do you resolve um,
Mhm.
any in like if the questions are wrong, if the data is not there, how do you resolve that? Yeah.
Right. Wonderful. The next question is from Krishna, and the question is: you showed result with ACOPF. What would it take to run different studies? How do you run different studies like PV analysis? I guess he's asking whether you did it and how different it is from ACOPF.
So PV analysis, I don't know whether you mean a continuation method, like a PV curve analysis, or do you mean a photovoltaic increase of renewable energy generation? But with ACOPF, it's the standard AC optimal power flow model that we run. So, and you have these different
Mhm.
n-1 cases. So each of these cases have different operating points because each correspond to a different contingency and so on. Or it
Right.
can have different renewable energy scenario.
Mhm.
So that was the case. But it can be, used for PV analysis, which is your continuation methods, or your renewable energy, like a PV hosting capacity or some other analysis.
Exactly. You're right. And Aliraza asked you, is the application, I mean, here, capable for faster cleaning force in distribution system operation? I guess he's asking whether you can go to this distribution in your software.
So we have not tried this on distribution, but I don't see any reason why it cannot.
Right.
If you have the necessary data and you have the necessary infrastructure to put this together.
Mm,
um, because irrespective of transmission and distribution, we are dealing with the physics of the grid, wherein
mm,
the laws of the grid, which is your KCL and KVL, are the same across transmission and distribution.
right,
So you will still, it's the data that you feed in.
right. And Jamie from XM asks you whether ChatGrid can be connected to other software, for example, asking the other software to do power flow uh, and running dynamic simulation. I guess it means interaction between your software and other existing power grid softwares.
Yeah, Jamie, thanks for that question. So the way that it is currently set up is that Exago is the tool that we use for simulation, and
Mhm.
it creates an output file that we then ingest in ChatGrid. So in theory, yes, if you have another simulation tool, if you create that the input file which is required, then it can straight away ChatGrid can take that and can run that. We've also kept our code bases. So there is the Exago code, but there is also within Exago there is just code for ChatGrid. So if you want to experiment with that or try that out, you can just there are some sample cases of input files that you can try out. Um, so yeah, if you want to have another input data format, then there will be some tweaks that will be needed for that. But it's not tied with any specific simulation tool as such. You can customize and modify that.
Mhm. Right. The next question is from Abi Penny. Abi asks you whether you try to incorporate other information into your analysis, like weather data, sensors data. One example Abi had is, can you do like generate a GLM file with loading data from coldest day in 2023? Have you tried incorporating
Loading
other?
a GLM file. I think that's a great case, Abhi, and I would, like encourage you to try that out. There is by GLM, I'm assuming you mean like a GridLab D file.
Mhm,
And yeah, as I showed some work on scenario generation that my colleagues are doing, and that
mhm,
is quite promising because they are able to generate the code that can be used for creating those scenario files.
mm,
There is work by my friend, from by my friends at NREL, who have a project called eGrid GPT, and they've shown some work on um, creating input files from, if I'm remember correctly, SCADA data or EMS data. And
mhm,
so there is precedence here that you can create the input files by using LLMs.
mhm.
Its accuracy and to what degree it is good, it's still, I think, an ongoing research effort.
All
So yeah,
right.
by all means, you can try it out, and at least from what I've understood talking with these people who are working on scenario generation,
Mm,
you can do this work in, very fast. And once you do it, then, you can reuse it over a period of time. So the effort required to put this together, because there is, there you can see so many tutorials on YouTube, as well as there is so much information on how do you create or how do you use these LLMs. It can be this. If you want to try it out, then yeah, by all means you can try it out pretty fast.
all right. Shri, do you mind to answer two more questions? Is that okay
Please,
with you?
I would love to answer two more questions, and if I can also ask, if anyone from the audience
Mhm.
is, can share their experience of working with LLMs, or if they have any projects going on, that will be absolutely fantastic to know about.
Right. Yeah. For the audience, if you have interests in Shri's research and work, feel free to contact him. If you want more information, you can contact the subcommittee and also the working group.
Yeah.
We will
And
make a connection. Mhm.
yeah, and not just my research, this is one research that is, on LLMs, but I'm pretty sure a lot of other people will have their own research or are thinking about problems that they want to solve using LLM. So I just like to have it kind of an open conversation if possible.
Right. And the next question is from Sweden, and Rahman from Dalaland University asks you, how do you see LLM for forecasting tasks like load forecasting, price forecasting, and other forecasting in power systems?
Yeah, so I think I don't yet know how much good LLMs are for those kinds of analysis, because there are traditional AI methods which have been used in load forecasting or any kind of forecasting, which have shown to
Mhm.
work, and they have done a lot of work on this, trying to train the model to get optimal forecasts. So I think
Mhm.
that kind of application probably fits better with the traditional sort of an AI, wherein you provide the
Mhm.
inputs and the outputs, and then it can predict uh, how the model behaves. With LLMs, as I mentioned, it's more of a generative AI kind of a technology. So it can, and it is, you also have to remember that there is a word called language embedded in this itself, so it works nicely with languages,
Right.
and I don't know whether it can work good with numeric data, which is what you require for forecasting. If you want to forecast words, then yes, I would say yes, but not with numbers.
All right. The next question is from Shwetaha. And Shwetaha asked you, have you encountered any challenge when you are integrating LLM in power grid data, for example, geospatial, numerical data processing? If you can share anything, troubles, that will be nice.
Let's see. So I can so not processing the data itself, but when it comes to how reliable or how accurate are the answers that you get from LLM, that's when you need to figure out how should you design your prompts, because a lot of this technology is based on hinting the LLM that because the LLM is very generic or general. And so you need to hint the LLM saying that you are a good data analyst, and it then tunes or trains its parameter, or then, sorry, not trains, but it basically changes its parameters to adapt towards towards what is being asked by the user. The second thing I want to say is, testing its reliability or accuracy. So the slide that I showed on, these different question categories using these different input formats, that was part of the investigation to see how can we increase its reliability. And based on that inference, then we decided, we should actually use a RAG-based model than a fine-tuned model for this.